today, and they are defined as a transformation in which the figure and its image have opposite orientations. You're going to be creating mirror images of a figure today. When you look in your bathroom mirror, does your head get any bigger or smaller? I hope not, too. It stays the same size, right? Unless it was a funhouse mirror. But when you look in your bathroom mirror, your face stays the same. All of these ones should stay the same. The figures, they won't change in size. Sorry. So that means they're isometric. Translations, reflections, they're isometric. They keep the shapes congruent to each other. Your first 5 questions on your worksheet are like the first question here. If point Q, which is at -1, 2, is reflected across the line x equals 1, what are the coordinates of its reflection? So the line x equals 1, here's the point x equals 1. So will it be a vertical or a horizontal line that passes through that? Vertical. So this green line here, this is the line x equals 1. I want to take Q and reflect it across it or flip it across that. A lot of counting again today. Q is 1, 2 from the green line, so then I'm going to go 2 more. 1, 2. Here is Q prime, the reflection of Q across that line. What would be the coordinates of Q prime? 3, 2, 7. 2 parts to this. What are the coordinates of Q if I reflect it across the line y equals -1? Well, the point y equals -1 is right down here. So will it be a vertical line or a horizontal line? Horizontal line. So now I want to take point Q in quadrant 2 and reflect it down below the red line. Again, you're just counting how far away it is from it. 1, 2, 3. So then go 3 more. 1, 2, 3. I'm going to call this point Q double prime. Put 2 tick marks on it. What would be the ordered pair of Q double prime? Good. -1, -4. So your first 5 questions are going to be similar to this. There'll be like 6 different points on the graph, and number 1 will say, reflect Q across the line, x equals 2. And then number 2 might say, reflect R across the line, y equals -3. You're just giving me the ordered pairs. Yes, sir. For Q or Q prime or Q double prime? Well, I'm just figuring out how far it was from the line of reflection. So I went 1, 2, so then I counted 2 more over. Does that make sense? Okay. Like if I could fold it on the green line, those Q's would line up. Or if I fold it on the red line, Q and Q double prime should hit each other. Neat. Number 2. Describe the transformation. Is it a reflection or a translation? Reflection, good. Across which line? Could be either. It'd be the equation x equals 0, which is also known as the y-axis. You have to draw in the line of reflection on like 6 of them today. You're just trying to find the line that would be right in the middle of your vertices. So you would be able to count A prime is 1, 2, 3 away. A is 1, 2, 3 away. So then I know the y-axis is in the middle. So when you go to draw them, you're just trying to find the line in the middle of them. Cool? All right, flip it. Number 3, we're going to reflect triangle ABC across the y-axis. Horizontal or vertical axis? Which one is the y one? Vertical, good. We're going to take ABC and we're going to reflect it across the y-axis. It's just counting. How far is each vertex, A, B, and C, from the y-axis? Then you do that counting again. So A is 1, 2, 3. So you're going to count 3 more. 1, 2, 3. This becomes A prime. B is 7 away, so then you're going to go 7 in the other direction. And name it B prime. Once you found your 3 points, make sure you label them, but then connect the dots so that you get a triangle. Your triangles should appear congruent to each other. Reflections are isometric. They'll keep them congruent. Over to the left of your graph, I've given you the the coordinates for A, B, and C, and you're supposed to fill in the coordinates for A prime, B prime, C prime. Julia, what would be the coordinate of A prime? Good, -3, 1. Ross, how about B prime? Morgan, how about C prime? You said -6 what? Good, -6, 5. Okay, so when you look at those blanks you just filled in, what do you notice about the coordinates of A, B, and C and the coordinates of A prime, B prime, C prime? How are they alike? How are they different? Okay, so when we reflected across the y, the only thing different is that our x's became what? Negative. Doesn't that make sense? If I started in a positive x zone and I reflected across the y-axis, then my x's would become negative. If I started in a negative x zone and I reflected across the y-axis, then my x's are going to become what? Positive. Your y's will stay the same. Okay, the next time we're going to reflect ABC across the x-axis now in the same graph. So now we're going to go across the green line up here. A is 1 above it, so then you're going to go 1 below it and name that A double prime. B is 3 above the x-axis, so then you're going to go 3 below the x-axis. That's B double prime. And C is 5 above, so then you'll go 5 below. I'm using double prime since I'm putting them on the same graph. If I had 2 separate ones, then it wouldn't really matter. Again, on the left, you're supposed to fill in the blanks for the ordered pairs for A double prime, B double prime, C double prime. Brooke, what's the coordinates of A double prime? Good, 3, -1. Brad, how about B double prime? Yep, 7, -3. Barbie, how about C double prime? 6, -5. Good. So now when you compare A, B, and C to the double primes, what changed? Your x's or your y's? And the y is changed by what? By becoming negative. So we were in the positive y zone, and then when I reflected across the x-axis, then I become negative y's. And vice versa. If I start negative and I go up, then they should become positive. When you reflect across horizontal and vertical lines, all you're doing is counting to figure out the difference or the distance between them. All right? Next one. Reflect triangle ABC across the line y equals x. Okay, your very first way that you graphed lines was to take x values and plug them in and then get out the y value. So if I put 0 in for x, what do I get for y? 0. So I'd have the point 0, 0. If I put 2 in for x, what do I get for y? 2. So I'd have the point 2, 2. If I put 3 in for x, what do I get for y? 3. So the line y equals x is this perfect diagonal that hits 0, 0, 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, 6, 6, and so on and so forth. So if I were you on that second graph, draw in the line y equals x. It hits the points 0, 0, 1, 1, 2, 2, and the other way. It'd hit -1, -1, -2, -2. And then see if you can reflect that triangle across the line. You guys, a line of reflection is kind of like a line of symmetry. If you were to fold your piece of paper along this line, your triangle, would it go down into quadrant 3? Shouldn't. If I fold it across this line, you should stay in quadrant 1. What'd you get for the ordered pair for your A prime? Okay, what'd you get for your B prime? What did you get for your C prime? Good, those are correct. C was at 5, 6, or excuse me, C prime. B prime 3, 7, and A prime you said 1, 3, right? If you look at your original plus U coordinates, A is at 3, 1, B is at 7, 3, and C is at 6, 5. What happens to the X and the Y's when you reflect it across Y equals X? They just swap. They flip-flop positions. Okay, so when you do a horizontal or a vertical line, you just count how far away you are from them. When you do the diagonal line, Y equals X, you just flip-flop the Y and X for each other. So like, if I wanted to reflect point P across this line, well, right now it's at 8, negative 5. So then P prime would have what for its coordinates? Negative 5, 8. I would just rearrange those two. So negative 5, 8. P prime would be way over there then. Okay. So Y equals X, you just flip-flop them. Questions? We have 4 left. Flip again. So the top one there, it says triangle XYZ has the given vertices of X, Y, and Z. Draw triangle XYZ and its reflection across the x-axis. So you're going to have 2 triangles on your paper. You need to first draw triangle XYZ, the given one, and then reflect it across the x-axis and make X prime, Y prime, Z prime. All right, so XYZ across the x-axis, that's your horizontal one. So you're just counting the difference. Y is 1 above, so then Y prime becomes 1 below. X is 3 up, so 3 below. And Z is 4 above it, so then you're going to go 4 below it. Make sure you label your points, connect your dots. They should appear to be congruent to each other. You want them to be congruent. Are we good on the first one? Cool. If you haven't already, do the second one. Y, Z. So if you're going to go across the y-axis, that's your vertical one here. Y is 1 to the right of it, so then Y prime is going to go 1 to the left of that green line, the y-axis. Z is 2 to the right, so then I'm going to go 2 to the left. And X is 2 on the left side of the y-axis, so then I need to go 2 on the right side of it. So then they're going to overlap. The line of reflection was just passing through the figure. Questions on that one? That one's a little goofy. You'll have a couple of those on your assignment. 2 more. Top of the next side. You're going to take that same triangle, XYZ, and you're going to reflect it across the line Y equals X. Remember, that's your perfect diagonal that hits 0, 0, 1, 1, 2, 2, 3, 3. Your Y becomes Y prime because it's sitting on the line of reflection. Z was at 2, 4. So if I flip those around, Z prime will be at 4, 2. And X was at negative 2, 3. So X prime is going to be at 3, negative 2. You should have 2 congruent triangles there that share that Y point. Okay, last one. You're going to take triangle XYZ, it's a different one. And you're going to reflect it across the line X equals 4. X equals 4 is a vertical line that passes through 4. So you can just count how far you are away and then mimic that on the other side. Your z stays the same, it becomes z prime. And then x and y there are on the right. Questions on reflections. Make sure you label your points. Okay, x prime, y prime, z prime, and whatnot.